Looks like a little bit slower here. Okay. Anyway, let's see here. So this is a chapter 6. The first thing is we'll start to learn the difference between FET and the BJT. BJT you have already studied in electronics 1, so there is no problem. And also I explained last class a little bit. Right? But you are sure you are familiar with BJT, right? The FET in this course actually mainly dealing with FET. There are various kinds of FET, and FET means field effect transistors. So from the name you understand the field effect, and the field, what is field, right? Electric field. And you studied the field in physics, and that's the main actually the concept of the field. And the field will be generating by using a voltage. And remember those BJT was a controlled by current. BJT and bipolar junction transistors, and field effect transistors. The FET will be controlled by the voltage. So we can call it a voltage control device. Okay, first we say similarities. What are the similarities? It says amplifiers. So what we have done in the BJT? BJT is amplifier. That means the signal you apply at the input, that is amplified at the output. Right? You have already did a lot of stuffs, right? If you consider those input signal, input or what can I say? Input. What was the input? Can you remember this BJT? What was the input? Let's say here, this is a. If you consider this is a BJT, so the input is in the base, right? And the output is always we consider collect from collector, right? And this is emitter, and uh, and this is a base, right? Remember, so the base was the input and the collector was the output. So IC, can you remember the difference between IC and IB? How much was that? Last class I mentioned that IC is how many times bigger than the IC? IC is how many times? Beta times IB. Remember, beta times IB. So, and what was the value of beta? Value of the beta was almost 100. Right? Is starting from 50. Right? The value of the beta is starting from 50 and goes up to 200, 300. Right? So that means the IC, you see, the collector current is, let's say, 100 times bigger than base current. So that means the current is amplifying in the BJT. Right? Understand? The collector current was huge compared to the input base current, and emitter was connected to the ground, so we did not collect any signal from emitter. But sometimes we collect though. But most of the time we collect signals. Output signal is coming from collector. Right? Understand this? So that means actually the transistor is amplifying this amplifier. Right? In here you see the beta times amplifying. The input signal is amplifying beta times and going to the output. So this amplifier and the FET is also doing the same thing because of the transistors, right? This FET, a same thing will be done. And switching device is, of course, is a switching device, right? When we apply some voltage at the base, and then a little amount of current will flow into the base, and then the transistor is turned on, right? That you have learned from BJT. How to turn on the BJT? You have to apply. If we consider the NPN transistor, this one, let's say this one is NPN transistor, right? NPN transistors. So then when you apply, let's say 0.7 volt or 0.8 volt in the base, and with a resistance here at the base terminal, then a little amount of current will flow to the what is called to the base terminal, and then this transistors will be turned on, and then we'll get the output current, right? how can you turn on the, but if you put the voltage, let's say 0.2 at the base terminal, then the transistors will not be turned on, and the current will not flow from the collector to the emitter or whatever, right? Here there's a VCC, right? In here, let's say here we put a VCC here, and after VCC, there is some resistance here, right? There is some resistance, and then we get output from here. Let's say this is a V out. Understand this? You studied this, right? This is BJT. And switching device, why is the switching device? When we don't apply any voltage at the base, these transistors will be off. And when you apply some positive voltage, then this one will be on. So that means there is an on off. So just like a switch. Same thing happened for the field effect transistors as well. And he says impedance matching circuits. So impedance matching means when you connect some other external service to the output, circuit to the output or input, the impedance must be matched, right? If the impedance does not match, then you cannot connect with this, right? Impedance should be matched in order to connect at the input or even output, right? So this is similarities, and dissimilarities. What are dissimilarities? The main dissimilarities is from the name. You see the name here. This is bipolar. B is a bipolar, right? And in here, FET, it did not say anything. So that means this is actually unipolar. This is the main difference, right? Unipolar, right? I don't know, it's hard to write. Anyway, it's unipolar device, and this is a bipolar, right? This is a bipolar. What is bipolar? Why is bipolar?
Sir, can you repeat why FH is a unipolar?
Yeah, that's we'll explain, because we will study a lot. So we'll explain when we go into the FET after a few slides. But you need to know what is bipolar, because this is not our topics. You have already studied. Why is bipolar? Can you tell me?
Sir, current emit করলে maybe মানে যে নর্থ আর সাউথ পোলে কনভার্ট হয় বা এরকম কিছু।
না বাইপোলার মানে কি? পোলারিটি হলো বাই মানে টু না?
Yes sir.
বাই আর পোলারিটি মানে এখানে আমাদের ইলেকট্রনিক সার্কিটে পোলারিটি বলতে কি বুঝি আমরা? Polarity মানে হলো electron and hole. Do you understand?
Sir, I can't hear you. Sir, I couldn't hear you, sir.
Electron and hole.
Yes, sir. Electron discharge negative charges and holes are positive.
Positive charge. This is the polarity.
Yes, sir.
This is minus and plus. So when the BJT, how the BJT works? Remember, there was a two junction, and
yes,
there
sir.
was a what kind of? There was a three pieces of two junction means three different kind of pieces: N type, P type, and N type. Right? And what was inside the N type?
Yes, sir.
What was inside the N type?
Sir, N type maybe sir a holes chilo, I guess.
Huh? তুমি গেস করছো কেন? তুমি ইঞ্জিনিয়ার না? ইঞ্জিনিয়ারদের গেস করো। তুমি স্ট্যাটিস্টিক্স এর ছাত্র না তো, রাইট? ইঞ্জিনিয়ারিং এ স্টুডেন্ট অলওয়েজ কনফার্ম থাকতে হবে, রাইট? এন মানে তো নেগেটিভ। তুমি এন মানে নেগেটিভ, তুমি এটাকে হোল বলছো কেন? নামই তো আসছে নেগেটিভ।
নেগেটিভ হবে।
এন ইজ কামিং ফ্রম নেগেটিভ থেকে, সো ইজ নেগেটিভ, ইজ অল ইলেকট্রন। হ্যাঁ, তুমি একটা যদি তোমার নেগেটিভ মানে ইলেকট্রন হয়, তাহলে পজিটিভটা তোমার যেটা পি হলো পজিটিভ। নেগেটিভ আর পজিটিভ সেখান থেকে তো এন আর পি এসছে। হ্যাঁ, তাহলে এখন তোমার ওইখানে যখন বিজেটির ভিতরে যখন কারেন্ট ফ্লো করছিল, তখন চিন্তা করো তো তুমি কি কোন টাইপের ক্যারিয়ার ফ্লো করছে ওর ভিতর দিয়ে? নেগেটিভ পজিটিভ দুটাই ফ্লো করেছে না?
স্যার
কারণ
বাইপোলারিটিটা স্যার তো আপনার হচ্ছে যে দুটোই ফলো করছে।
হ্যাঁ, বাইপোলার মানে কি, তোমার এরকম তো ছিল, 3 পিসেস ছিল।
Yes,
এটা
sir.
ভালো ড্রয়িং করা যাবে না, তাহলে এখানে মনে করো 3টা পিস ছিল, এরকম ছিল। এখানে মনে করো তুমি যদি এন লেখো, এন, এটা পি, আবার এখানে ছিল এন, এন, তাহলে কারেন্ট কোথা দিয়ে গেল? এই পাশ দিয়ে গিয়ে যদি এই পাশ দিয়ে মনে করো কালেক্টর যদি আমরা বলি, লেটস সে দিস ইজ এ কালেক্টর, এটা কালেক্টর, আর এটা এমিটার যদি আমি বলি, আর এটা বেজ, এটা যদি বেজ বলি, তাহলে দেখো তো তোমার কালেক্টর কারেন্ট কোথা দিয়ে বেরোয়? রাইট সাইড দিয়ে না?
Yes, sir.
আর কারেন্ট আসে কোথা থেকে? লেফট সাইড থেকে।
Yes, sir.
দেখো
Left side থেকে
এখন
স্যার এসে
কিছুটা বেজে যাবে, কিন্তু কিছুটা বেজের ভিতরে যাবে, কিন্তু মোস্ট অফ দ্য কারেন্ট উইল গো টু দ্য কালেক্টর। তাহলে দেখো তো ওটা কিভাবে যায়? এই যে প্রথমে এন এর ভিতর দিয়ে যায়, তার মানে এন এর ভিতর দিয়ে যখন যায়, দ্যাট ইজ ইলেকট্রন, electron is flowing here, and then we'll go to the p area, and inside the p the carrier is whole, and again we go, and this current is going through the n area, and there is a carrier electron. So that means the current is actually generating because of both type of carriers, electron and hole, both are actually contributing to the current, right? Understand here?
Yes, sir.
So this
Yes,
is,
sir.
that's
এখন
why it's
বুঝতে পারছি স্যার।
bipolar. That's why it's bipolar. But we'll see in FET there is nothing like that. Either there will be only electron, only N, or there will be only P. Not both. That's why we call unipolar. That means one pole, one polarity. We'll see that, right? We'll study the more details. So that is so this is a very important, because when you go for interview, they will, most of the time they ask the questions, what is the difference between BJT and BJT's name is always coming as a bipolar, but why is it FET unipolar? And we learn. So, and this one is, says this one is BJT is a current control device, and the FET is a voltage control device. We'll see that, right? How is voltage controlled? And is a FET have a higher input impedance. Input impedance is very high, and BJT has a have higher gain. This one is better though, gain, in order to just magnifying. In here you see gain. What is gain? This is the gain. You see beta is the gain. When you put a IB, let's say 1 milliampere input, then and beta value of the beta is 100, then collector current will be 100, right? So it will be very big again. But in case of FET, the gain will not be that much, but the input impedance is very, very high. Actually open circuit, when you have open, you see the BJT in here, can you see here? The B is connected to the body of the transistor, right? In here there is no gap, right? There's a collector, base, and emitters, all are connected in this point, right? In the here connected. But in case of FET, we'll see that they are not directly connected. There is some gap here. So when there is a gap, that means the impedance is high. And then what is that? FETs are less sensitive to temperature variations and better suitable for integrated circuits. Yeah, that's why we are studying, right, for integrated circuit, because we want to know modern tools, right? Modern circuits, all are integrated circuits, and they are made out of FET. So that's why it must be sensitive to temperature. Otherwise, right, it will may give us malfunction and will disturb. And the FETs are generally more static sensitive than BJT. Okay, so then we'll go to our main topics. There are several types of there are more, actually. There are more FETs, but in here we are showing only those we need to study in this course. And there are more FET actually. Right. So this is the first one is a ZFET. We call it junction FET, and then the next one is a MOSFET, metal oxide semiconductor. This is M is coming from, J is coming from junction in here, and MOS coming from metal, and then oxide, and S for semiconductor. And the MOSFET is a two types. One is a D MOSFET, and there is a and there is E MOSFET, enhancement MOSFET, and there is a depletion MOSFET. Right, so we'll study these four types of MOSFET first, and then we'll design some other circuits by using those FET. Okay, so now this one is construction. Now we see why is unipolar. Now you can see here. This is the construction of the FET, the basic J FET. But this one is N channel FET. But okay, in here, actually they are showing all in one time. What can I do? Okay, maybe I can draw in a place. Okay, first the left side. A little bit take a look at the left side, because I want to draw something on this. There are two types of JFETs. Right? Actually, all kinds of FETs are two types. Just like the transistor, just like the BJT. BJT has a two types: N-type BJT, P-type BJT. Have NPN and PNP. So similarly, all kinds of JFET, MOSFET, DMOSFET, EMOSFET, everything has N-type and P-type. N, P. And all of those has N-type, P-type. Right? Very similar to all of those, right? So we are not care about that. So that means there will be, and this N-type means N channel. This N means N channel, and this means P channel. Okay, now we'll see. Here is N channel, P channel. And very similar to the BJT, this JFET, all FETs also have a 3 terminal. But the names are different. Right? The names you already learned: beige emitter collector for the BJT, but in here is not. Here is the names are different. Here the name is source, drain, and gate. Right? Actually, source is actually equivalent to emitter in case of BJT, and drain is very similar to collector, because you know the drain. What the drain does? Drain always collect all the water, right? Waters or whatever, all the dirty stuff, right? All a drain. That is called drain. And source means the place where something is coming, and that is source. So it's same thing. So our emitter was the source, because it was emitting some current, and from collector we were collecting. In here the collecting is drain, is the collecting. Drain will collect. And the gate is actually controlling the base. Like a base, how was the base? The base was the controlling component. Right? When we apply a voltage to the gate, then the transistor was used to turn on. Right? And when it was we took up those power, then the transistor was off. So that is the controlling device. Controlling terminal. In here, the gate is the controlling terminal. So when you apply voltage at the gate, then the transistors will be either on or off. Right? It depends on what kind of voltage you are applying, either positive or negative. Right? So that is called gate. So now you see how this FET is actually constructed. Okay, I'm drawing on top of this one by using a red color. So it is actually done. What is done? Initially, taking a rectangular pieces, right? Let's say this is a rectangular pieces of silicon, N-type. Understand? This is a rectangular pieces of N-type silicon. And after that, in here, okay, we put a different color. After that, in the right side, we added some P-type area here. You see, in this area we added P-type material. Right? You know what is P-type, right? P-type material is like a boron, right? You add, or you can consider any material with a positive ion, right? In here, so the basic is the main component was N-type, the body, the main part was n-type, and then we added a small area in the right side is p-type, and the same thing in the left side also, right? In here, in the same size, right? In here we added p-type material, like let's say boron, right? Now this two side is p-type in here, left side and right side, right? And now what do we do? We make it short circuit with this one in here, right? And then we put a this and we apply a voltage here, right? This is the gate. Understand how the construction is done? Now look at the table and look at the right diagrams. The first we took this rectangle, this is sky color rectangle, and then the right side we apply p-type material or a hole. We added some extra hole in this side and hole in the left side also, right? Then there is a rectangular area, but practically this is not a rectangle. There to be an oval shape, right? But this is an ideal case, as looks like a rectangular shape. So now this is done. The construction is done. And then these two sides are short circuited, and there are two P. The two P are short circuited in here, just like this. And we put a gate. We consider this is a gate, and now this in here in this terminal. Okay, we put a. No, maybe you cannot see what color. Okay, black color. Okay, now this one. Let's say this one we consider a source or drain or whatever. Okay, both are same terminal, right? Both are same. We can consider any side is source and any side is drain, right? Understand? I can consider this one source and this one drain. It doesn't matter because this is both exactly symmetrical. But the book, it says in the upper side is drain and lower side is source. Yes, normally we do. This is a standard because yeah, there is a reason why we put the source in the bottom. Now you see this construction. Construction is looks like if you consider the current flowing from P to that P, PNP, it looks like a PNP transistor, right? It looks like a PNP transistor, but you see the two P's are actually short circuited. In case of BJT, this 2P is supposed to be either emitter and collector, and the base inside the base N is supposed to be the base. But in here you see the same body, right? Same body, and the top terminal is considered as a drain and the bottom terminal is considered as a source, right? But it doesn't matter to me, যে কোনোটা consider করতে পারো, but both are same. But normally we put the source in the bottom in case of n-type JFET. This is an n-type JFET actually. This is n channel. This is n channel, not p channel. This is n channel. N channel means the channel will be made out of n-type material. Means there are lots of electrons, right? Negative charges are there in the pool. So this is a blue, right, or sky area is full of electron, right? So this is called N, and this side is full of hole. But there are few electrons there and there are few holes in the n-type area also, but doesn't matter. So now why is it's called channel? Because the current will flow from, you see here, from current, we can say carrier. The in this case this is n channel. Because of the n channel, n means negative, so the negative will be coming from ground, right? We know that our world or our ground is the universal source of electron, right? আমরা universal negative কাকে বলি? আমরা ground কে বলি. So that means ground is the actually universal or unlimited source of electron. And holes, from where we get holes or positive voltage, we get positive holes from the positive voltage, right? When you have a positive voltage, then we get holes, right? But in here in this transistor, the source is coming from ground, means electron coming from ground. That's why we know that ground is always in the bottom side, not in the top side, right? High voltage is on the top side and low voltage is always in the bottom side. So but in here, in this case, our transistors, our source is electron, so the electron will be coming from ground. So that means this terminal, the bottom terminal, we have to connect with the ground. That's why this is in the bottom side, right? And this is source. Sometimes we call it VSS, right? Not sometime, actually from now on is a VSS. And why is that? Because of the source. You see, S. Remember in BJT, you used to call VCC, right? In here you see VCC. In case of BJT, the top voltage was VCC. Why is that? Because that terminal was connected to collector. The C is for collector, and we used to use 2C, VCC. But in this case, there is no collector, there is no base, there is no emitter. So, but in here we have a source and we have a drain. So we call then this bottom terminal, we call it VSS, and the top terminal we call it VDD. In this side we call VDD because of the drain, right? In case of FET, from now on, all kinds of circuit have a VDD here and VSS in the bottom. And VSS, because this is source, and source is actually this N-type, and N-type source is coming from electron coming from the ground. That's why this is in the bottom side. So now how does it work? So this is a construction. It's very simple construction. You see, it looks like almost the same type of NPN, but in the middle part is a little bit bigger, and the 2p type are very small, and 2p are shorted. That's the main difference. And the drain and source, or you can say collector and emitters, are in the same body, but in the opposite terminal, right? Now, how does it work? Oh, there's a very nice here. You see that they explained with some real world example. Like this is let's say the source. From the source, water is coming from the source, and this is a gate, right? The tap, water tap, and the drain is going to the right. Your home, the water is going to the drain. So that is a collector, right? And the water coming from the source, and you can control by using the gate, right? You can close it or you can open. Right? This is a physical example of the FET operation, right? But in here, and in that is not a big deal. In here, okay, no, we'll go before in here. Okay, now look. There, how many junctions here? You can see there is a junction in the left side. In here, there is a junction here, PN junction, and there is a right side. There is another PN junction. Understand this? There are two junction, right? তোমরা শুনতে পাচ্ছ? আমি তোমাদের কোনো রেসপন্স শুনতে পাচ্ছি না।
স্যার শুনতে পাচ্ছি। জি স্যার শুনতে পাচ্ছি।
আচ্ছা
Yes, sir, we can hear you.
হ্যাঁ, রাইট। দুই একজন তোমরা মাইক্রোফোন অন করে রেখো, যে বুঝতে পারছো কিনা একটু বলো, নাহলে আমার ডিসকানেক্ট হয়ে যাচ্ছে কিনা বোঝার উপায় নাই। Okay, anyway, so in here you see the two junction in the left side, one junction, and another junction in the right side, and both are PN junction, right? আমরা last class যে আমরা দেখিয়েছিলাম যে BJT is a diode. So there's a diode right here, PN diode, and in this side NP diode. So these two diodes actually in here. Actually not two diodes. There are thousands of diodes around here. All around here there are hundreds of diodes, right? And the diode's polarity here looks okay. I mean, I can draw here. So there is a one diode is here, right? And let's say another diode. There are thousands or millions of diodes are here, right? The P in the left side and right side is N. But in this side, in the right junction, there are diodes, polarity is opposite. There will be in this side is negative and right side is positive, right? In here. So this is the kind of diodes. Diodes are in the face to face, right? So there are lots of diodes around this junction, right? So now what will happen? Let's say if we apply, if we do not apply any voltage to anywhere, if we do not apply to any voltage to anywhere, then what will happen? What happened to a PN junction? Last class I explained. Let's say this is a PN junction. So what happened if we do not apply any voltage? This is a P and this is N. What happened if we do not apply any voltage? There will be a depletion region, right? That's we learned last class. There is a depletion region, and if we apply forward bias, this will be disappeared. And if we apply reverse bias, then the depletion region will be bigger, right? And that's we learned last class. So now this same thing in here, you see this area. Okay, let's say this is black. No, put a yellow. Okay, that says in here, you see this area shaded. I am putting a yellow. This is a depletion area, right? Because without applying any voltage, this is a depletion region, right? In this both sides, right? Both side PN junctions, there is no voltage applying at the PN junction, so there is a depletion. This area is a depletion area, is a yellow color. And you understand this? Right? Okay, I think you okay. Now we apply voltage. Right? Now we would like to apply voltage here. And we'll see what happens. Right? In here we do not apply, without applying any voltage, and we can see a smallest depletion region in here, and those are symmetric. Look here, in this side and this side is all symmetric. Right? You see this is symmetric, right? Both sides symmetric. Now look carefully. This is straight vertically down. Now we'll go to the bottom one. Here, look what we are doing here. Let's say here we are applying. You see, look at the gate, right? This is a gate. Apply positive voltage. Oh no, we still keep it 0 volt. Okay, now we apply voltage in the other side. Okay, we can do different way. We can apply this side first and this side no voltage, and this side. Okay, they are doing this side first in here. So now what are you doing here? So in the gate volt, there is gate voltage is still 0, right? Get in here, you see, there is gate voltage 0, drain voltage 0, source voltage 0, right? There is no voltage in any terminal. Now in this case, you see the gate voltage is still 0, but you see the drain, I already mentioned, the drain should be the positive voltage and source should be the negative. You see here, drain will be VDD, right? Positive voltage, and source will be the negative, right? Source will be negative voltage because of the electron. We need an electron, right? For example, if we want water in the output, so we must supply the water, right? So in the source. So in here, in the source, this is the ground, and you see the negative terminal here. negative terminal is connected here, negative terminal is connected to the source here, and positive terminal is connected to the drain, right? Now what will happen? Now this source is here, so because of the source is here, so that means electron will coming from the source and also grounded. You see here, ground is the universal source. The source means electron coming from here, from the ground, and will go upward. Right? Electron, see here, the small number is showing here. Electron will starts to flow upward direction. What does it mean? Electron will be attracted by the hole in this VDD, right, in the drain. Right? Here is a positive charge. You see the positive VDD in here. So the electron will be attracted by the holes. So the electron will move from bottom to the top. And then what happened to the current? Current will be opposite, right? Current will be opposite. There will be current here. Right? This is a current. Current will be going from top to bottom, and electron will go from bottom to top. And is here is said, you see ID. ID is the current, drain current. So current is going from top to bottom, and electron will go from bottom to top. So now you see what this one is channel. We call it channel. You see now, because the electron is flowing from the ground and going through the N-type material and going to the drain. Right? Now, তুমি কে যেন কোশ্চেন করেছিলে যে ইউনিপোলার কেন? দেখো তো এখানে যে এই যে ক্যারিয়ার যে ইলেকট্রন মুভ করছে, এটা কি কখনো হোলকে ক্রস করে? হোলের ভিতর পি টাইপ ম্যাটেরিয়ালের ভিতর দিয়ে যায়, নাকি শুধু এন টাইপের ভিতর দিয়ে চলে যায়?
স্যার এন টাইপের ভিতর দিয়ে যাচ্ছে।
শুধু এন এর ভিতর দিয়ে। দেখেছো চ্যানেলটা শুধু এন এর ভিতর দিয়ে চ্যানেল, ফ্রম বটম থেকে টপ পর্যন্ত যাচ্ছে, যে ইলেকট্রনটা যাচ্ছে, এবং ইলেকট্রন ইজ ফ্লোয়িং থ্রু দ্য এন টাইপ ম্যাটেরিয়াল, and n type material means is full of electron, right? So actually the electron coming from the bottom and pushing the electron in the bottom area, and then the next electron will be moving, pushing the another one next to the to that electron, and then gradually moving up, and then going out through the top side, right? So that means the electron, that means the carrier in this carrier is electric. There is no other. There is no crossing of p-type material. You see, there is no current going to the p in here, left or right. There is no current, right? So that means the electron is actually flowing from bottom to the top and through the channel n-type. So that is a unipolar. That means this electron is never crossing any NP or PN junction. It is going through a unipolar area, only one polarity area, right? Only unipolarity area of electron, or only n-type material, only through the n-type material, right? The carriers are moving only through n-type material, so that's why we call it unipolar device. Right? Any question about that? Why is unipolar?
No, sir.
Okay. Now I have a question for you. Tell me why this is not uniform. In this, you see that now the depletion region is bigger. You see this depletion region here is in this and in this. This both sides are same though, but you see the bottom side is shrinking. Is comparatively less than the upper side. You see, if you go to the top figure, is uniform. You see the top and the bottom is same, right? It looks like a rectangle in both sides, left and right. But in here you see, in the left, in the bottom area, a little bit less than the upper area. In here you see in this area, the depletion region is bigger. In this area, depletion region is bigger than the bottom area. Why? Anybody? Any idea? No? Okay, now this is a depletion region, right? So why the depletion region becomes bigger? When the depletion region becomes bigger and how? Remember last class I explained those PN junction. When do you, if we need to make the depletion region bigger, then what do you do? What kind of voltage do you apply? Cannot remember? Forward bias or reverse bias?
Sir, reverse bias.
Reverse bias, good. এখন বলো যে রিভার্স বায়াস যদি তুমি কম রিভার্স বায়াস দাও আর বেশি রিভার্স বায়াস দাও তাহলে দুটাই কি সেম হবে সাইজ ডিপ্রেশন রিজিয়নের সাইজ? তুমি মনে করো রিভার্স বায়াসে তুমি 2 ভোল্ট অ্যাপ্লাই করলে আর একবার তুমি 3 ভোল্ট অ্যাপ্লাই করলে রিভার্স বায়াসে, তাহলে কি তোমার ডিপ্লেশন রিজিয়ন, দ্য উইডথ অফ দ্য ডিপ্লেশন রিজিয়ন একই থাকবে?
স্যার থাকবে না।
কোনটা বেশি হবে?
স্যার ওই যে 3 যেটা ওটা
বেশি রিভার্স বায়াস দিলে বেশি হবে। যখন
Yes, sir.
0 দিয়েছো তখন মিনিমাম থাকে। when reverse bias was, when there was no voltage, then minimum. Now if we apply reverse, if we apply forward bias, sorry, hello, just a moment. হ্যাঁ, না একটু বাকি আছে। আচ্ছা বলতে কি okay, I had a call. Okay, now okay, so what I was talking, when the reverse bias is bigger, then the depletion region becomes bigger. Okay, so এখানে দেখো what happened in the bottom area, in the left side, in here, you see this, the P type is, look at the P, in the right side the P, the voltage at the P is remain 0. You see here this P, or in the even in left side the P side terminal here, this voltage is 0, and in here we said voltage 0, right? If the voltage is 0, so that means we are not changing that side. However, in here, you see in the channel, is the channel voltage, what is happening in the channel? Is it in the, look at your VDD, is it, there is a line like this. What does it mean? That means this voltage is increasing, right? No, even if you don't increase, still let's say the VDD is 5 volt. When you say VDD is 5 volt, then that 5 volt will be dropped through this channel. Understand this? Let's say here, let's say if we have a power supply here, let's say if we have a power supply here, let's say 5 volt, and here there is a resistance here, so and if we connect this, so let's say if this is 5 volt, why does this 5 volt drop?
Sir,
Let's say 5 volt is supply here, this whole 5 volt will be drop in the resistance, right?
Yes, sir.
Yeah. So now in here we have applied VDD. So this whole VDD will be dropped in the channel. Inside the channel there is a resistance from the bottom to top. Bottom to top there is a channel. So inside the channel there is a resistance. So when there is a resistance, so that means there is a voltage drop, 5 volt drop. So 5 volt is at the top. Let's say আমরা 5 volt যদি ধরি তাহলে এটা 5 volt হবে আপে and 0 volt will be here. 0 volt and here will be 5 volt, right? And what about the middle? Middle point will be 2.5, right? So if we consider the universal, so 2.5. Now if you look, if we go above the middle point, the voltage is higher in the channel than the bottom, right? In here voltage is less than the voltage in here. Okay, we can use a different color. Let's say here. So voltage in this area is higher than the voltage in the bottom area. Understand? So when the voltage is less, that means this is a less reverse bias. Let's say this is a 2 volt and there is a 4 volt. So when the 4 volt, that says depletion region is bigger, and here is a 2 volt, so the depletion region is less. Understand? So this is the main region to have these different sizes of the depletion region. Right? Okay, any questions so far? If we don't have questions, okay, then move to the next. Now you see what happened. If we increase this, if we increase the voltage gradually, then what happened? At certain point, you see here, they will touch each other and will be blocked. You see, they will be touching each other, and this phenomena is known as pinch off. This is name is pinch off here, right? This is called pinch off. When if we increase this voltage and gradually increase, then at certain point, these two depletion region will come close to each other and they will touch each other, and that point is known as pinch off. But still current can flow even though they are pinch off. But since we are applying very high voltage, so because of the high voltage, the electron will have a more energy, so they will jump from here to here, right? The electron will jump, so still current will flow even after pinch off, right? And that is called saturation. You see, this is the point of pinch off. This is the point of pinch off, and after that the current becomes constant, will not increase, right? It will be fixed. Okay. Any questions so far? Okay, I would like to okay, stop at this point actually, because I'm not feeling comfortable using this PowerPoint, and also this is editing tools. We cannot write that much, right? We need to explain more details with the whiteboard. So anyway, any questions so far up to this point?
No, sir.
No, sir.
I will stop the recording first.